Let's go back to that last problem we did, and let's take a look at the pieces of information that we knew. That is, we knew A, B, and gamma. And let's discuss in detail for which types of problems we'll be able to solve using the law of cosines. So here, we very frequently classify triangles based on what we know about them. So in this case, we have what's called an SSS triangle, S standing for side, A standing for angle, S standing for side. And this type of triangle is one for which you know two sides and the angle in between those two sides. And when you have an SSS triangle, then you will always be able to use the law of cosines to solve it. In order to see why, let's go back and take a look at our generic triangle with the law of cosines on it. So here we go. So let's say, we knew these pieces of information, but it doesn't matter if you know those three pieces of information or if you know two other sides and the angle in between. As long as the angle is in between the two sides that you know, then you'll be able to use the law of cosine. So for example, if I knew AC and beta, then if you take a look at this second law of cosines, you'll see you'll be able to figure out B, because we know A, C, and beta, and all that's left is B. So as a statement here, we can, and I'm going to change this can to typically, so we typically use the law of cosines to solve triangles, to solve what kind of triangles? Well, definitely SAS triangles. So SAS triangles. Let's think of what other types of triangles we can find or using the law of cosine. So let's imagine that instead of given two sides of an angle, let's imagine that we're given all three sides. Well, then in each one of these law of cosines, there's exactly one unknown, and that's the angle. I suppose I'm usually circling the thing that is known, but so many things are known here, A, C, B, etc. And each one of these law of cosines, the only thing that's unknown is the angle. And so you can use the law of cosines 3 times, or perhaps what I would do is use the law of cosines twice to figure out 2 of the angles, and then you can use the fact that the sum of the angles is 180 degrees. And we'll do an example like that soon. When you're given the 3 sides, that's called an SSS triangle. And we typically use the law of cosines to solve those types of triangles as well. Now, we do not use the law of cosines when we have only one side given. So any triangle in which you're only given information about one side, you will not be able to solve using the law of cosines. And I'll also remark that for triangles where you're given 2 sides and an angle that's not in between those 2 sides, then you can technically use the law of cosines to solve this type of triangle. If you go to the second law of cosines here, then you'll see you know B, you don't know A, you know C, you don't know A again, you know C, and you know beta. And you can technically use this second law of cosines, but it's much more common to use a different law to solve those type of problems. So I would say, while you can use the law of cosines for SSA triangles, we'll typically use a different law that we'll learn later. And that something else is called the law of sines. And what I get for this right-hand side is negative 34.657. So cosine of gamma has to be negative 34.657. So what is gamma then? Remember, we're trying to find a gamma for which cosine of gamma is equal to this number. However, take a moment to remember that cosine of gamma, the range of this function, is -1 to 1. That is, cosine of gamma cannot be smaller than -1, and it cannot be larger than +1. So solving cosine gamma is -34 is not going to give you any solutions. So you could say a couple things. You could say no solutions. Well, no solutions since the range of cosine of gamma, that is the outputs of this function, is all the numbers between -1 and 1. Or if you don't happen to notice this at the time of doing this computation, you can try to do the cosine inverse of the right-hand side, but on typing this into the calculator, you would get what's called a domain error, and then you would be reminded, oh, this equation does not have any solutions. So there is no gamma which satisfies cosine of gamma is -34.67. So from this discussion, what I'd like you to understand is that for SAS and SSS triangles, we'll typically use the law of cosines. But if you ever forget that these are the types of triangles you can use the law of cosines for, you can always draw a generic triangle and circle the pieces of information you know, as long as you only have one thing, one variable that's unknown in a particular law of cosines, you can use the law of cosines. Let's do an example of finding the angles in an SSS triangle. So we have A is 7, B is 5, and C is 50. So we know A, B, and C, and if we look at our law of cosines, we'll be able to figure out the angle in every one of these law of cosines because we know A, B, and C. So for example, we know here that 50 squared has to be equal to, well, that's C squared. That has to be A squared plus B squared minus 2 times A times B times cosine of the angle opposite to this side, which is the angle opposite to C, and that angle is gamma. And now we can solve for cosine gamma and use our inverse cosine function. So cosine of gamma, I'm going to do a few steps in one. I'm going to subtract 7 squared and 5 squared, and then I'm going to divide by -2 times 7 times 5. So 50 squared minus 7 squared minus 5 squared, all divided by -2 times 7 times 5. When something like this happens, then your conclusion is that there are no triangles for which A is 7, B is 5, and C is 50. So my answer here would be that there are no triangles that satisfy the given conditions. And you can just simply say no triangles, but I'll be a bit more verbose and say that satisfy A equals 7, B equals 5, and C equals 50. Essentially what's going on here is this side is just too long. If you're trying to construct a triangle in which two sides are very short and one side is very long, there's no way to connect these three lines together to make a triangle because you could never close the triangle. So now that we've seen how perhaps we can have triangles or be searching for triangles that don't exist and how to recognize that there are no triangles, let's change this problem a little bit so that we can actually find some triangles that solve these conditions. So let's change this to 10. So if we change that to 10, then this and this would become 10 squared. And so this right-hand side would become -0.371. And so cosine of gamma would have to be -0.371. And now I should note that if you have a negative on the right-hand side, that is okay in the sense that you can find solutions as long as the negative on the left, or excuse me, on the right-hand side here that I've circled, -0.371, is not less than -1. So if it was something like negative 1.5, then you're not going to be able to find a solution. But the number on the right-hand side is between -1 and 1. And so we can find gamma to be cosine inverse of negative 0.371. And when we do that, we find, let's erase these stray marks, that gamma is 111.804 degrees. Now I'll use a second law of cosines, that is this second one here, to figure out, I know B, A, and C, remember, to figure out what beta is. So B squared, and B is 5. That's going to be A squared plus C squared, so 7 squared plus 10 squared, minus 2 times 7 times 10, times the cosine of whatever angle is opposite to B, that's beta. So I can solve for cosine of beta, and I get that cosine of beta is equal to, I'll subtract these two things from both sides, so 5 squared minus 7 squared minus 10 squared, divided by negative 2 times 7 times 10. And this ends up being 0.886. And so beta, that's going to be cosine inverse of 0.886, and that's equal to 27.660. And again, I have this added caveat here that these are approximate answers. So beta is approximately 27.660 degrees. Then once you have gamma and beta, you could use the law of cosines again to figure out alpha, or you can just simply say that alpha is 180 degrees minus gamma minus beta, and that gives me 40.536 degrees. And once again, of course, this is approximate. So use the law of cosines twice, and then after we use the law of cosines twice, we can use the fact that all the angles add up to 180 to get the last angle. Just keep in mind when you're solving side-side-side triangles, if you ever come across an equation which is cosine of something equals, and then you have some number on the right-hand side which is bigger than 1, so something like could be like 2 pi 7, or smaller than -1, anything like -7, -1000, -1.1. If you're ever trying to solve cosine of something equals to a number like this, you'll get no solutions. And that amounts to that there are no triangles which solve the given parameters of the problem.